say 1 plus null equals 3, right?
Right. Yeah. So regular SQL doesn't quite have variables like that.
Okay.
Yeah. I mean,
Okay.
there are ways of doing different things, but yeah, in short, it really doesn't have that concept in the simplest standardist part of it.
Okay. Thanks.
One area that is practically relevant for nulls is like when we were talking about ORMs earlier in the day. So Django ORM, I think it's called, is the object relational mapping that connects Django to your database. In Rails, it's called active record that connects Rails to your database. And when you get into that portion of the curriculum, I'm sure you'll learn how to restrict what you can put into the database through the ORM. So you might think, well, if I can tell my Django code to never put null into some field, then why do I need the constraint? And the reason that it's good to think about the constraint on the database layer is because it's like another safeguard against null data. So we try to do it on both levels. We try to do it on the ORM level and to say, no Python code gets to put in a null value into the database, but then we also tell the database no anything gets to put null value into your tables. And when you do both of those, you have a really good like double system going on. So I don't think we'll really get to demonstrate that, but I just wanted to point that out.
Yep. Yep. That's the way it is. So the last thing we want to talk about here with nulls and what goes along with nulls is coalesce. So coalesce is a function that takes a variadic number of arguments. You can pass it 1 argument, 10 arguments, whatever. And it will return the first one that is not null. So for example here, if I say coalesce 1, 2, 3, it's going to return 1 because that's the first thing that's not null. Even if I change it to like, 1 null 3, it's 1. But if I were to say null 3, it returns 3. So this is really useful, as you can see above, if we want to make sure that we don't have null values. So I mean, that idea of like, what was the sum of our call duration? Well, if we never called them, it really is 0. It's not null. And if we never called them, I suppose an average of a 0 thing is perhaps a little weird to think about, but I think it's fair to say that that's 0. So then we can run this and we get rid of those null values altogether. There's another operator or keyword that we can use if we really do care about if something is null. We already talked about like we can't say null equals null. What we can say is null or is not null. And that particular operator or phrase or expression, is how you handle null values when you really want to tell the difference between, this is null or this is not null. All right, any questions on that before we move on to our next lesson? Cool, okay.
Actually, just have one real quick.
Sure.
On lines 190 and 191, for that inside that coalesce argument, we have the zeroed out timestamp. How does that play in the argument?
So this is the second value that gets passed to coalesce. So if some call duration ends up being null, this is the value
Okay.
that's used.
Okay, got it. Thank you.
Mhm. So if we looked at our agenda here, we're planning on doing data modeling at 3. We're going to take another break again around 2. Before that, we are going to move to this time clock lesson. We actually have more lessons than we have time for today. We're going to basically do about half of this one and then a new lesson that we just added in the last few days. But we're going to move over here to time clock, and this will give us a little bit of a of some more exercises, especially of sorting and, you know, finding newest and oldest, stuff like that. And we will do some of this. We're going to work on this till our 2 o'clock break, and then we're going to do some querying on a COVID-19 database and see how this type of stuff can actually have like very real world, you know, importance. We'll do a little bit of a time clock first. So if you all want to move over to time clock directory lesson.sql. And down in the terminal, we're going to exit the terminal, or we're going to exit psql, which I can't believe we got this far and we never talked about how to quit. \Q is one way out of it. If you're on a late version of Postgres, exit will work. If you're on an old version of Postgres, exit won't work. But the way I prefer is if you hit Control-D, it shows that I typed \Q, but I really didn't there. I just hit Control-D. Control-D is the insert end of file, or it's the end of file character. So that will work, like if you're in Python, that'll work there as well. I'm gonna hit Control-D. If you're in Ruby, that'll work. If you're in Node, that'll work. If you open a new bash shell, that'll work. So Control-D is the convenient way of exiting a REPL, you know, an REPL, a read eval print loop program, of which your command line terminal, your shell is one, your different programming language, interactive modes are ones, and psql is one as well. So we'll Control-D to get out of that. We're gonna go up a directory, then go over to time clock, and then we're going to start doing the same type thing we did before. Then it specify every step along the way like I did before, but we're going to create a new DB, call it time clock. And then we are going to use psql, and we are going to connect to the time clock database. Okay.
Hey, Jack, I had a question on connecting to the database.
Okay.
So when we're in, you know, when we're developing something down the road and what's the correct way, you know, to do this? I mean, this is for ease of use on our end, but like, would you create a user with a specific username and password? Because if we have like, you know, if our laptop gets stolen or something like that and we don't have any credentials set up for our DB, anybody that knows pSQL can just, you know, get right in. So is there a specific way to, or were you going to go into that later?
Well, so as far as security goes, if it's on your laptop, even if you set a password, I mean, that can be bypassed like pretty trivially. So if it's a matter of securing data on your laptop, you really need to be using encryption. If you're on Mac or I think Windows Pro also has like basically it's practically just a checkbox that you tell it encrypt my whole hard drive, and you probably would want to do that. If you're talking about, well, how about connecting to a production database, then yeah, you definitely should have you know, a strong password and all of that. Does that answer your question, or I'm not sure if I.
Yeah, no, that makes sense when you're just in a local development environment, keeping your machine secure. You mentioned when you connect to a production database, I'm guessing that's probably out of the scope of this, but is that is that something that you would typically like use credentials for, that you'd have to set up a user for in P-SQL, or is that done on the server that is hosting your database? You know what I mean?
Yeah, well, I mean, it definitely supports users. I mean, we could, create user, actually, I don't think I need comments there. Yeah, I just created a user. There's a whole bunch of stuff that Postgres has as far as access control. You can control stuff based on like what IP address people are coming from. You can require them to connect over SSL. You can use like client-side certificates. You can use traditional usernames and passwords. Postgres has like groups and roles where you can create a user, then assign them to a different group. You can wire it into the PAM, the pluggable authentication module for like Linux. And then, anything that you could use there, like a YubiKey or a one-time password generator thing, you can wire stuff in there. There's a lot of ways of doing that, which basically ends up depending on what your specific, company needs are. And it also depends on like, do you have individual users connecting to the database? You might have a system where, all the developers just have like a deploy key or something like that. Or if you actually have like an accounting department or a data science department, maybe each person has their own credentials. There's a lot of different ways it could be set up depending on if it's a application database or if it's like maybe a data warehouse and people are doing reporting. Whatever you want, it probably supports it, but deciding what you want is actually a pretty big topic.
Copy. And that sounds like it'll be all something that the database administrator sets up ahead of time, and we kind of just plug in where we fit in, kind of thing.
Yeah, usually if you're not going solo, yeah, you'd probably have somebody who at least acts as your DBA.
Got it. Thank you.
Mm-hmm.
Jack, is this maybe a time to talk about like migrations and stuff, and how you would actually like manipulate a database on a server, or do you think we should wait for later for that?
Yeah, I think it's as good a time as any. It is kind of related. You want to
Okay. Yeah, sure. So some context to like how we're teaching today that is probably missing, but like it's sort of intentionally left out by us is, so when we're learning SQL, you're in Postgres, you're in the Postgres SQL REPL, and you're typing, and you're trying things and making mistakes and breaking things and dropping the database and recreating it. And that's really good. That's how you learn. I think that's like how you should learn, or like that's how we focus our day here. But when you're doing this stuff practically, it's a lot different. In the sense that so if you want to change something, like we were talking about access to a production database, right? You might be able to get access to it. You might give yourself access to it, or your database administrator might give you access to it, but it's actually pretty rare that you would be connecting to that database at all. What is more likely to happen, on a good day, when you need to change the database, you're going to be writing a script that changes the database. Has anyone ever heard this term of a migration script? Yeah, so a script is a a migration is a script. In Django, I'm sure it's written in Python, and in Ruby on Rails, it's written in Ruby with a special language called Active Record. But you're writing a script that both changes the database the way you want to change it, and then also you're trying to write a second script that changes it back. So all these queries or typing into the terminal with their hands, you might figure those out in a situation like this, but then you'd put the change SQL into the change script, and then you'd put the rollback SQL into the rollback script, and you would test this script on a local copy of your database. So you'd pull down a production copy or something similar to the production database, and you would run the migration, and it would run those commands, and then you'd look at the database and see that it had been changed, and then you try running the rollback, and you look again and see that you have undone what you've done. And so then once you're happy about that, you'd be checking this into your repository, and that code would be deployed to another environment, usually like a staging or a QA environment, we would call it. And then those scripts are going to be run again, at least the migration, maybe not the rollback, but the migration is going to be run on that server. And if there's any errors or issues, you would fix them. And then last but not least, you'll run the same scripts on your production database. And the QA staging and production database are supposed to be like as close to the same as they can possibly be. You might like remove some sensitive information, but like they're almost identical if you can. So in the end, the thing that actually changes your production database is a machine kicking off a command that just runs the command. So by that point, there should be no surprises, and you should know very confidently, I wrote this command right, it runs against this kind of data set, and if it ever goes wrong, I can run another command, it'll just take it right back. And that's how this like cowboy coding experience we're having today becomes very predictable in the real world.
Yep. So for an example of that, I just pulled up some stuff from my current production project. So this is an example from like 6 months ago. So I needed to create a table, needed to create some indexes on it. In this particular system I'm using, this magic comment is what determines what is the up part of the migration, what is the down part of the migration. And when I run this, I have a tool that I run this against production, and it'll just run this, and I don't actually type it in there. And this actually, like this here, I actually ran this against production this morning. So this is like literally how we do this stuff. And typically how that works is there's a number somewhere in the system. Let's see if I get that wrong. And what it does is it looks at the version number that the database is currently at. It looks at the number of the migration, and then it decides whether it needs to migrate stuff or not. So there's a bunch of tools that do this. Rails has one built in. I'm 99% sure Django has one built in. What I'm actually using here is something I wrote myself. But there's a ton of tooling just to wrap these scripts together. Okay, so going back to the time clock thing here. We're going to start by just creating this table of employees. So obviously we mentioned time clock. Our domain here is a very simple employee database that has some time tracking. And we're going to try and write some queries to maintain and to report on the employee data. So to start with, we need the list of employees. And in this case, we're going to be smart and we're going to split first name and last name instead of mashing them together like we did the last time around. And we're going to record like when the person was hired. So for some of this, what I'd like to do, we've got a lot to cover here, and we already know we're not going to get through all of it. We've got probably 2 or 3 days worth of material here. But even so, I'd like to get through as much as we can. So I'm going to start going a little faster here. And what I'd like is, if something becomes unclear, just speak up. But we're going to go a little faster for some of this stuff here. We're just going to like copy and paste. So we're inserting a few records here. We can look at the employees table. We got these people that now work for us. So some of these exercises, we're just going to work through a couple of these together. And then if you want to do some extra stuff after hours, we have more exercises here, and we do have the solutions in the other file as well. So there's an answer key if you want to do some extra credit, so to speak. Let's talk about like what we do for write a query to find the newest employee. When we think newest, oldest, and we're just trying to find which one, that to me makes me think of sorting and then limiting. So we're going to do a select star from employees. We're going to say order by hire date. And then we're going to limit. And actually, here's another thing. These queries are simple enough that like Jake and I are usually do it just in like a single step. But once you get to anything more complicated, and for that matter, probably what you're doing right now, I like to do it iteratively. So like oftentimes, even though I know this isn't what I want, I'm going to start with select star from employees. Then I'm going to say order by, I think it's hire date. But I don't even want to think yet about, is this ascending or descending? I don't want to think about that. I can just eyeball it. Okay, so I guess if we're looking for our newest employee, this is wrong. So, okay, I guess I want to do, what is it? Descending, I guess is what I want. Oh, okay, that looks better now. I guess I want to limit it. And you kind of just iteratively start with the simplest thing you can do that does something, and then do as little steps along the way. And every step along the way, then if something doesn't do what you expect, then you have, oh, I just made this tiny little change, so I have a tiny little place to look at what went wrong, instead of seeing, oh, I just wrote 20 lines of code and something broke. I wonder where it is. It's a lot easier to debug one line of code at a time than 20 or 200. So for the second exercise, obviously this is pretty trivial. We just change the order of ascension. I'll leave those bonus ones for if you want to figure that out later. Let's jump to this thing here. How should we represent period of time the employee is working? That's kind of an interesting one. If we say that they worked from 2 p.m. to 6 p.m., well, that's enough. But how do we represent it when they did not clock out yet? What if their shift is right now and it starts at 1 p.m. and they're scheduled to go till 6 p.m. Or it doesn't even matter when they're scheduled to. They actually clocked in at 1 p.m. How do we handle what the end is?
Null?
Maybe null.
Yep, you're both right. It would be null. And this is where that gets a little messy, in that in this case, null does mean empty. It doesn't mean it's unknown that they've already clocked out and we don't know about it. In this case, it really means they haven't clocked out. It means empty. And usually you will know one or the other. It's very, very rare that you would have one field that potentially could be in an unknown state and potentially could be in an empty state. Usually it's either this is unknown or this is empty, but you don't have the possibility of both. However, the problem is, as far as which one it is, it kind of is just contextual, and either you need to have the data model commented, or, you know, more likely, the person who wrote it probably will just expect you to figure it out, unfortunately. But we'll pause that for a second, because we're going to talk about that a bit more with this TSTZ range. But here's another one that you may have heard the expression, there's only two hard things in computer science or software development. Has anybody heard what those two things are? Good, I get to be the first one to tell you them. So there's only two hard things in computer science. The first one is cache invalidation. It's cache as in C-A-C-H-E. And we're not really going to talk about that. But the second one is naming things. And the third one is off by 1 error. So if you've ever done C, you'll totally get that. But anyway. But that core idea of there's only two hard things and one of them is naming things, that is a very, very real thing. We deal with abstractions. We deal with ideas. And if we don't have the word for something, or if we don't have the name for something, you know, it's kind of like an old philosophy question. Can you even think a thought if you don't have the words for that thought? And, you know, philosophers argue about that. But at the very least, if we're trying to build something and we don't have a name for it, or we don't have the right name for it, that is a problem. And I know that, you know, Jake and I both have spent many, many, many hours, you know, arguing, agonizing, thinking, trying to figure out what is the right name for a given concept. In this case, we're just going to go with worked shifts, just because we don't want to spend those hours right here. But you can easily see, well, maybe it's work period. Maybe it's just shifts. Maybe it's hours worked. Maybe it's time clock entries. I'm sure between the 24 of us, we could probably come up with another dozen or two names that might be reasonable. And maybe some of them would be even better. But coming up with an accurate name can be really, really tricky. But we're going to run this create table statement. And there's one new thing you probably haven't seen here before. That is TSTZ range. That is timestamp with time zone range. And that is the thing, Postgres has data types that represent ranges of things, whether they're numbers, dates, or times. And this is a really nice thing, because without it, we would probably do something like this. We'd probably do something like this. Start time and end time. But that can actually represent invalid data. What if we said we started at 1 p.m. today and we finished at 11 a.m. today? Well, that's totally nonsensical. But we could record that. Well, a range type does not allow you to have invalid ranges or backwards stuff like that. And that's one of the things as far as data modeling goes, and that's what we're doing when we're deciding what tables and columns to have. We're doing some data modeling. Ideally, we want to make it impossible to represent invalid data. That's part of like what we did when we have a type, when we say this must be a number. Well, we're making it impossible to represent the error of putting text in a number. When we say employee ID is not null, we are making it impossible to represent a shift that did not have an employee. That'd be invalid. When we say references employees, that's a shorthand for creating those foreign key constraints like we did in the last lesson. We are saying it is impossible for a shift to be an employee that doesn't exist. And with TSTZ range, we are saying it has a start time and it has an end time, but it cannot end before it starts, for example. So what's next here? We should create an index on that foreign key. Now we haven't really talked about indexes yet. You're going to get the 30-second version here. I'm sure we've all looked at physical books that have an index in the back. And you want to look up some topic, you look it up in the index and it says, oh, it's on page 137. That is significantly faster than reading the entire book to find where that topic is, right? It's the same thing here. We can tell it, make an index on this column, and then whenever we search for a value on that column, it can look in the index and take a shortcut. Just look there and then find out which page to look at instead of reading every row in the table. So as a general, again, as a rule of thumb, anything you have that's a foreign key, you should also add an index for it. So now let's add our first shift. Now the syntax for how TS/TZ ranges, or timestamp with time zone ranges, is a little weird if you haven't seen it before. I'm using on line 40 here, I'm using its constructor function. When we actually select from it, it's showing us the text format. And if you've done any math with ranges, it might look a little familiar because it supports open and closed on both ends. So the square bracket is, or another way of putting it would be inclusive or exclusive, might even be the better phrasing. Square is inclusive, the square bracket, and parentheses is inclusive. And that's important because this next thing we're going to do here. So some of this, I'm just trying to show you that it can be done. As far as the exact syntax here, this really is just a copy and paste. I'll give a 50,000 feet explanation of it, but to actually use this is going to be something you're going to want to look up. What we did though is the first thing there where it talks about B-tree gist. B-tree is for, binary tree. Gist is, what is it? Generalized, oh boy, I'm blanking on what it stands for, but it's a particular type of index. And that particular type of index lets us create an exclusion constraint. And what we're excluding is we're saying, do not allow there to be any rows where the employee ID equals and the time range overlaps. In other words, it doesn't make sense if we have an employee and he has two shifts going on at the same time. He can't clock in twice and get double pay. He needs to clock in, clock out, clock in, clock out. Now let's try this. So we are going to try and insert something that overlaps. So let's try this first one here, line 47. It blocks it. It won't let us insert that because we already have that exact same shift. Let's look at the next line. Well, what if it doesn't what if it's not equal? I mean, we could have done that with a uniqueness constraint or a unique index. But this just is overlapping the beginning. And it still blocks it. What if it overlaps the end? Still blocks it. What if it's entirely contained? Still blocks it. What if it's smaller? What if it exists entirely inside of it? Actually, I had that backwards. The previous one was, what if it was entirely contained? And this one is, what if it entirely contains? So all the different ways that it could overlap, it detects and blocks. Even if we say it's an unbounded range, where that means that he's clocked in and he's never clocked out, well, that means that it essentially is the entire future. That's blocked as well. So we talked about how we represent an unbounded, or they clocked in but they haven't clocked out yet, and that's where we use null. And on the output, we can check for that with upper infinite or upper INF. So that lets us see who's clocked in and who has not yet clocked out. The upper and the lower functions, those let us access just one part of it. So we could say, just get me the lower part of the range. And that gives us a timestamp TZ back. If we said the upper one, we haven't finished this yet, so we get null. One of the nice things with timestamps is they can be subtracted and we can get an amount of time. So if we run this, we can see, oh, the first shift that we recorded was 5 hours. The next shift was null because upper time range for that one gives us null. Well, null minus anything is null. So we get a null value as the output. Ranges are really, really cool. And I've got the link here to the documentation if you want to look at more stuff. They have a bunch of things that you can do. You can check for overlap. You can check for being all to one side, all the other. You can check, is a point inside of this? A lot of mathematical functions if you need that type of stuff. Let's see here. So we're just going to skip these exercises. We'll leave that as you can look at the solutions if you want. We're just going to run through here. Let's get rid of our existing shifts. And let's create some new shifts. So let's run this and then let's talk about that. Generate series is kind of interesting, isn't it? So generate series lets us put in a start time, an end time, and a, how would I say, the step. If you want to do it with times, you can also do something like numbers. And the generate series function actually returns a table. So this is a nice way of just generating some data. And in this case, we're using it in time or date mode. And we are doing it to get just the last 30 days. We can cross-join this. This is one of the few places where we actually would use a cross-join. And we could say, give me a date record for each employee for the last 30 days. A few more just kind of random things. They're seemingly random, then we're going to put them all together. We can ask for a random number. We can also use the ceil function, which rounds up, combined with random. Now we'll get a number between 1 and 4. Let's put all this stuff together. Now we have an employee ID and the time range that they may have worked. We get one of those for each day, and it's random hours that starts at, we're going to get a random hour between 500 and 900, or 5 a.m. and 9 a.m. And that goes to 10 a.m. to 2 p.m., somewhere between there. Now this is just selecting it. So, well, actually, we're going to make one other change here. We're going to say, people don't work every day. So how about we say where random is greater than 0.2? Random by itself is the random number between 0 and 1. So we're saying they're going to work 80% of the days. Now, obviously, since we've got random stuff going on here, if you're following along and running this on your computer, you're going to be getting slightly different results than I am here. But we can see that, you know, occasionally, like, okay, everybody worked on the 27th this time and this time, but not this time. So we get kind of some interesting random data. Now, we're going to chain this together with one more thing. Remember when we talked about, or I alluded to the fact that when we insert into a table, we really are inserting a table or a data set. And I said we're going to use values, but you really can use other things. Well, here's an example of that. We're going to insert the results of this entire select statement. And we're going to say, execute that select statement and insert the results into worked shifts. So I ran this, it inserted 95 rows. I can do select star from worked shifts now. And there we go.
Jack, how are you when your output goes past the end of your terminal? How are you shortcutting to the bottom?
So let's see here. It's so much muscle memory. Okay, so Shift G. So capital G goes to the bottom. And GG goes to the top.
Thank you.
Mm-hmm. Yeah, those are actually Vim commands that somehow have kind of infected all these other programs. But if you ever use Vim, that'll work there as well. Okay, we kind of just ran through a bunch of stuff quick to get some random data there. Now we can do some interesting things. How about we say, how many hours in total have been worked? Well, on my computer, it was 464 hours. Since there's randomness involved, I'm guessing everybody else got something slightly different. This is an example of a few things we've talked about before. Sum is a function and we pass it an expression. So this expression, before when we did a sum, we used just a column value, but we can use any expression. So here we're going to use the expression of, the upper time range minus the lower time range, and it sums them all together. So we've got a bunch of exercises here. I'm going to jump to the solutions and let's just look at the solution to 3.1 because this one is kind of useful. We've run this and this is actually a useful query. Given our time clock thing, okay, who are employees? How much did they work?
Like right now.
Sorry?
I think that was just a hot mic.
Oh, okay, okay. All right, so we've got one more thing to show here, and then we're going to take a break and then come back for our final lesson. I think it'll be a fun, or if not fun, at least informative lesson. So this last thing here is we're going to talk about the halving clause. So we've talked about where before. And the where clause gives us the list of rows, or every row gets passed through the where clause. And if it evaluates to true, we include the row. If it evaluates to false, we exclude the row. But that happens before group by. What if we want to filter after group by? So we got this. What if we want to filter by, in this case, over 100 hours? Now it looks like that's everybody here, so I'm going to need to change that for my example. what we can do is we can say having. And in the having clause, we can include aggregate functions. I'm just going to make this one, I'll make it 115, I guess. And the having clause is basically the same as where, except it happens after group by. And you can kind of visually see that in that the having clause literally comes after group by in the sentence, if you will, of the query. I know we've kind of raced through this, but does anybody have any questions on this? Which I'm guessing there are. Yeah.
Hey Jack, back at foreign keys, whenever you're indexing, do you create, if you have multiple foreign keys, do you create an index for all of them?
In general, yes, you should.
Does the when we create an index, does the index actually live on our table?
I mean, it's connected to the table. I mean, when you say live on the table, I'm not sure exactly.
Yeah, if we were to view the table for all the columns, like we wouldn't see an index column, right?
Oh, right. So the index is an index is actually a implementation detail. I believe the SQL standard doesn't actually even define indexes, because your query will work the same. Your query will get the same result either way. It's just it may run far, far faster if you have an index on it. But as far as actually like viewing the index, you never actually do anything like that. By running this command, create index, it's essentially a declarative thing that you tell Postgres, make this index and always keep it up to date. But we never actually can look at it. You know, it's just Postgres knows it's there. So if the query we run could benefit from it, Postgres will tend to use it. I'm using a lot of vague terms there because there's a lot that actually goes into that. There's a command called explain analyze, which you can prefix any statement or any select statement with. And it'll tell you what it's going to do, how long it thought it would take, how long it did take. They're kind of difficult to read. But in this case, there's only a handful of rows and we wanted all of them, so it did a sequential scan. If we were to do something on a larger table, like with thousands of rows that had an index, like I'll go ahead and delete, on mine here, I'll delete all the, what was it, work shifts, I guess it is, delete from. And then I'm going to create, I'm going to go back from the current date back, say 1,000 days. So this is going to create a bunch of records. And now if I were to explain analyze, where I ask it for the records for one particular user, see, what did we call that? Employee ID equals 2. And again, I certainly don't expect anybody else to read this. I usually have to look it up to try and understand what's going on when I do it. But the important thing here is if you see the word index, that's usually good. If we did not have the index, let's see here, I'll just drop that index for a second. We rerun this command. We can notice the execution time was slightly higher. and it did a sequential scan. This would make a much bigger difference. You know, even a couple thousand rows is not that many. But if we had 1 million rows, that could be a very big deal.
Thanks for that, Jack.
Mm-hmm. So any more questions?
I got one on the create table statement. If you scroll up, Jack, I think, yeah, can you go over the generated by default as identity?
Yes, but the short answer is that's a magic incantation that you should just repeat when you want when you want an incrementing integer. That's the short of it.
When you want one, I'm sorry.
When you want an integer that just is incrementing, you know, you want ID 1, 2, 3, 4. That's your magic incantation you use there.
Oh, okay. What's the difference between that and serial? Because I know serial is another way to do that, right?
Yeah, serial is the older way that Postgres had. They both still work. I mean, this is roughly the equivalent. Those are roughly equivalent.
Okay.
The difference is serial is Postgres specific, and generated by default as identity is the SQL standard. The other difference is the way Postgres actually implements this is with something called a sequence. And you can actually manipulate these directly. And it internally is doing this. But it also has some internal bookkeeping that says, like, this employee's ID sequence is connected with this column on this table. And if we drop the table, it'll automatically drop that sequence. And there are some like edge cases, like if you duplicate a table where, okay, I duplicated the table, but do I want to have 2 copies of the sequence, or do I want to use the same sequence? There are some like weird edge cases like that the generated by default as identity style handles better. So because it's the SQL standard and it handles certain weird edge cases better, I prefer this style, but 99.9% of the time it like means exactly the same thing, or it works exactly the same way as just saying it's serial.
Thank you.
Mm-hmm. Any more questions? Cool. Well, let's take a break till 2:15, and we'll have a kind of a fun little query exercise. And then at 3, we're gonna switch over and Jake's gonna lead us through a data modeling exercise. And so far has been, you know, simple, contrived things. We're gonna do something somewhat more real world and definitely more timely. So let's close this stuff out. We'll Control D to get out of this database. And let's open up the COVID-19 directory. We'll open up the lesson here. And in our terminal, we're going to do the same thing we did before, where we're going to change into that COVID-19 directory. Oops, oh, need to go up a level. Then we're going to follow these instructions here of we are going to create a new database. We are going to import some data. This data came from covidtracking.com, which is a project from the Atlantic. And it gives us some raw data. We're going to do some queries on some COVID-19 data. So we're going to start with P-School and COVID-19. You can use \D to see the list of all the tables. You can use \D and then a table name to see all the columns in that table. There's a lot of them. So take a look there. Then take a quick look. We definitely don't have time to read through it because it might take 10 or 15 minutes to read through. But take a look at this link that I've highlighted here of covidtracking.com/about-data/data definitions. Let's take 2 or 3 minutes just to scan through that quickly and get an idea for what all these fields mean. Okay, so I give you about 2 minutes there. And I'm sure, unless you're some sort of crazy speed reader, you definitely didn't get through it all. Because there's 13 pages just of the data definitions. Now, that is a bit of an indicator of how difficult data analytics can be. 13 pages just to explain exactly what these fields mean. So that's going to be a running theme. We're going to talk more about that as we go through this. But let's start with just this first query here. How many total cases have there been in the US? So I downloaded this data just last night. So this should be fairly up to date. And we have, what is that? 8.6 million cases. And we were able to get that just by summing the positive column, which if we looked at that data definition thing, we found that positive is cases confirmed plus probable. And we have basically a paragraph explaining each one of these. And I'm just going to read this off to you here. Total number of confirmed plus probable cases of COVID-19 reported by the state or territory, ideally per the August 5th, 2020 CSTE case definition. Some states are following the older April 5th, 2020 CSTE case definition, or using their own custom definitions. Not all states and territories report probable cases. If a state is not reporting probable cases, this field will just represent confirmed cases. So all that just for one column. And what that says is how much confidence can we actually have in this number? Well, we can have confidence that, you know, presumably the Atlantic did what they said they were going to do. So we can have confidence based on that definition it's the right number. But the data is only as good as what they were able to get. And, you know, they talk about, oh, well, you know, this organization had one definition before this date and it had one definition after this date. So as far as, you know, we wrote the correct query here. We got the exact number, you know, according to the data we were given, we got the exact answer. Does this answer correlate with reality? Well, presumably fairly closely, hopefully, but that's a good question. So let's do a couple exercises here. Let's change this query and let's see how many total deaths have there been. And then let's see how many tests have been performed. Okay, cool. Yeah, it might have been silent because I haven't actually said anything for the last minute or so because I wanted to give you all time to go through these exercises. So for the how many total deaths, we can actually just take this query that we already have of the sum of positive. We can just change it to sum def. We get 217,418. And we can do the same thing with how many tests have been performed. With, let's see here. I think it's total test results. To look at the
Jack, on the sum function for the deaths, so that integer value 217,000, that's actually a not a cell value, but yeah, like a cell value. It's not like you're summing up, you know, all the because you have where date equals. So what's that summing up exactly?
Okay, great question. So let's actually just look at the data a little bit of the entire table. And this is where this fancy pager I'm using is kind of handy. If you remember at the end, I can show you all where to install this. You can just use brew or it's in most package managers, I think now. But to answer your question, the death column is a cumulative total. So this data is already a little pre-processed. So the reason we're saying the date is we just want to get the most recent numbers. So for example, if we were to select a single state, so I'll just say where state equals Illinois, and let's add an order by date descending as well. So you can kind of see here, it is a running like cumulative total. So what we're doing when we say get where the date equals 10/26, it's already cumulative up to that point for each state. So we're saying get the latest count from each state.
Thank you.
Now the tests one, this is an interesting question as well. And again, this would be the type thing we would perchance need to spend a lot of time reading that 13 pages of data definitions. In this case, we'll just do the total test results, and that says there have been 133,750,060 tests performed. But if we look at the details, there actually are more rows or more columns that give more detailed information. You end up with a bunch of further questions. You know, is this, some people have been tested multiple times. You know, does this mean that a third of the US population or more than a third has been tested? Or does it mean some people have gotten tests, you know, every week or something like that? You know, maybe they're a doctor and they need to get a test every day so they don't go infect, you know, patients or something like that. This column doesn't tell us that. Some of the other columns might, and some of the other columns might not, depending on which state they come from. You know, that's why they have 13 pages of definitions and disclaimers and clarifications of like, what does this number actually mean? But this number here, so we're just saying how many tests have been performed, not how many people have been performed. So another question we could ask here, what is the overall case fatality rate? There's a few slightly new SQL things here. One, we're saying the sum of one thing divided by the sum of another. So aggregate things can be added, subtracted, whatever. They can be used as, you know, expressions as part of other expressions. But this part here is new, the colon numeric. So here's what that does for us. When we sum an integer, the result is an integer. And if we divide two integers, the remainder gets thrown away. So we just end up with 0. So this colon and then a type, that is how you tell Postgres to convert from one type to another. So the sum of def and the sum of positive are both integers, and we are telling it convert to numeric, where numeric is a decimal type in SQL. In other words, it has arbitrary precision. It's not floating point where it can easily lose precision, but it also is not an integer where it loses fractions. So we have basically, numeric is the type stuff you'd expect to come out of your calculator. It's that type math. And we end up with, 0.025 or, a little over 2.5%. Now, why is this number so high? If you've looked at, recent CDC stuff, the overall fatality rate shouldn't be nearly that high. Did we make a mistake in our query? Well, it's always possible, but in this case, I don't think it is the case. And this is another thing of like, how do we deal with queries and data? Well, what does our data actually mean? Well, we actually answered that with our question. We were being precise there, case fatality rate versus, I believe the term would be like incident or infection fatality rate. So a lot of people are asymptomatic, or their symptoms are mild enough, they never go to the doctor, they never have a test. So our rate is only going to be factored based on people who, for whatever reason, thought they should have a test, and that test was positive. All of these things kind of are telling us a little bit that it is really difficult, even with the best of intentions, to get the right answer to queries. Another interesting thing is, remember back to those 13 pages of data definitions. How many exceptions there were where they said, oh, okay, well, this number was calculated this way until this date, and then we switched to this other number. There's this other way of formulating it, except these other states didn't do it that way. Or, somebody, dies on the 1st, but it doesn't get reported to the 10th. What day does that show up on? Should we go back and correct the numbers of the 1st, or do they show up on the 10th? Well, according to the Atlantic, sometimes they do both, or they do either, rather. In some cases they go back and correct, in some places they show up later. This is more in the data science realm of SQL than it is purely the developer role, but those roles can tend to overlap a lot. When you're a developer, what are some of the things you're going to do? You're going to be building dashboards for the managers where they say, I want to see how many sales we're having every week, or how many new customers showed up, how many people visited and didn't actually buy anything, how many people added something to their shopping cart but did not check out, and it's been more than a day. Maybe they want to see that on a dashboard. Maybe they want to send an email to all these people to say, hey, if you finish your checkout within the next 4 hours, we'll give you 5% off. And they're going to send them an email based on your query. Well, you kind of better hope your query is right. So one of the big things with data science or reporting is cleaning the data. And that's what there's about another 50 pages of stuff, if you go to another page on that Atlantic site, where they actually talk about where the data comes from for each state. And they have usually several paragraphs for each state saying, the data comes from here, but this particular state does this particular weird thing, which we're allowing for in this way. And this other state does this weird thing, which we're handling this way. And they've basically done all this cleaning for us. But it's not uncommon that if you're needing to find some particular data or do some sort of analytics, it's not uncommon at all that at least half the time will be spent cleaning the data, trying to figure out, what does this mean? Oh, we've got a bunch of missing records here. What does that indicate? And then once you have clean data, there's also the question of, okay, I wrote a query. It does give me an answer, but did I ask the right question? And I think this COVID stuff provides a real world example. I mean, I don't know about you all, but I watch the news a lot and I see a lot of things that seem to contradict each other. I was at, oh, it's this, and then, oh, the next day it's that, and then it's this again. And it's not necessarily that people are trying to mislead. It's just there's a lot of different ways you can phrase the question and get very different answers. So that's something as developers and data scientists, we need to be very careful and be very precise, what exact queries are we writing, what answers are we getting, and what confidence do we have in them. That's something in this table. If you look at the whole table, they even have a column that says, data quality grade. How much confidence do they actually have in this data? That's kind of interesting too.
There's a D near the top.
Yeah. What is that, American Samoa, I'm guessing? I think that's what it is. This is the 50 states and 6 territories, I think it is. So I'm guessing it's American Samoa. You also see that some of them are those nulls, oh, unknown, or they didn't provide it. Okay, well, for pure SQL, let's do another couple of queries here. So how about, what was the peak ventilator usage? That was something that was a really big deal. Several months ago, people were afraid, are we going to run out of ventilators or not? So let's run this query, and we'll run it to see the answer. Then we're going to backtrack a little bit and say, how would we write this query? So according to this data, the worst day was May 7th, and there were 7,070 ventilators in use. Now let's start removing some of this query, because like I said, I'd usually build it up iteratively. So we probably would actually start with maybe something like this. So we want to select the date. And this group by here, this I'm using a little bit of shorthand. For group by and order by, you are allowed to just use a number, and that number is the column position. So I'm saying group by column 1 and then order by column 2. And I'll do that occasionally for ad hoc queries, just to save a little typing. If this is going to be in long-term production code, it's probably better to spell out exactly which column or which expression it is. But we can start, okay, if we're just going to group by it, we're going to group by the date, and we're going to sum and see how many people were on ventilators each one of these days. Well, then how about we order by column 2. I could have said that whole sum on ventilator currently thing, but I just don't want to type so much, so I'll just say order by 2. Okay, well, that's going from smallest to biggest because it's ascending. I guess we really want descending. Oh, well, that's weird. So that brings up something we haven't talked about before. If we're ordering, where do nulls go? Well, by default, you know, they would, in this case, they're considered the lowest number, I suppose. Or I guess we're descending, I suppose they're considered the highest number. Excuse me. But by saying nulls last or nulls first, we can put them wherever we want. So I really don't care about nulls, so I'm going to say nulls last. Now we have which were the highest ventilator usages, you know, every day. So it looks like, yeah, May was pretty bad. April, looks like everything is in April or May until we get down to about half the original usage. But if we just care about what was the absolute peak and when was it, then we also add, okay, limit 1, just get me the top one. And that's how we get that answer back. All right, we just talked about why nulls last. Few exercises for you. I'll give about, say 4 or 5 minutes for this. Let's try and see if we can do these exercises. They pretty much should be similar in form, the previous queries we've done. And the solutions are in solutions.sql if that's necessary. For questions as well.
How did you list it when you wanted to pull the data specifically from Illinois? Like
So,
the deaths of just Illinois.
So what I did there is I added a where filter for state equals IL.
Okay, and are you able to have 2 different where statements? Like if you wanted to do where state equals Illinois and where date equals 2020, 1026?
Yes, you can. In fact, I can't believe I didn't mention that before. That's a grave omission. So SQL supports the keyword and the keyword or, and they do basically what you think. You can combine 2 Boolean expressions into a single expression. So if we want to have, you know, something like this, and obviously we could do or as well. I mean, that really wouldn't make sense, but But yeah, you can just do that.
Cool, thank you.
Mhm. Okay, we've had about 4 minutes there. If we look at the solutions, we can see that, you know, all those questions on 2.4 are pretty similar, just variants of the questions we asked before. And you notice that, like, for how many patients are in the ICU now, you know, we used currently when we wanted to find how many have ever been. We used cumulatively. Now, based on this data here, could we have answered these questions without the cumulative fields? And if so, you know, how would we do it? If not, you know, why couldn't we?
Use the max function.
So we would have done like max on what? On what field would we do max?
In ICU cumulative.
Right. Well, that's what I'm saying is, could we answer this question if we didn't have ICU cumulative, if we just had in ICU currently?
Couldn't you just add them up from all your ICU currently days?
Well, let's try that. Let's see if we get the same results. So if we see our solution for how many are in the ICU. Let's see, how many total were in the ICU, I guess is this one. And if we were to add them all together, we would be saying in ICU currently, and we would remove the where clause because we want to add all of them up. This answers a different question. So let's actually make this a little more concrete. Let's say, you know, Adam goes into the ICU today and Bill goes into the ICU today. So our current for today is 2. They both are there tomorrow. So our current for tomorrow is 2. How many total patients have been in the ICU?
2.
2.
Yeah.
So the answer to our question here of can these questions be answered without the cumulative field is no. Because to do that, we would have needed to have detail records of, you know, Adam went in the ICU on date, you know, the 1st and left on the 10th. And, you know, Bill went in on the 1st and left on the 5th. But we don't have that level of detail. We only have a snapshot each day, but we have no idea if there's 10 people there today and 10 people there tomorrow, if they are all the same people or if they are all different people. So whether the state data sources that this is drawn from or whether it was the Atlantic one of the two of them or both of them is actually summarizing this data already for us. And in this pre-summarized form, we actually can't answer that question if we did not have the cumulative fields. It's actually really interesting. There's a number of places online you can get data. And if you want to, both as a SQL exercise and maybe just kind of to understand current events a little better, if you want to download some of this data, there's a lot of interesting stuff there. If you go to the CDC, they have more raw data. There was one data set I was almost going to use, but it's like 500 meg, and getting everybody to download that and set up seemed like that would be a little bit of a problem. But it actually is several million rows of per patient data, you know, somewhat anonymized. You know, it just, you know, this is their age group, this is their sex, this is when they were first diagnosed, you know, this is the result. And from that type, and that would be the detail level you would need to be able to produce these aggregate values. You would need to know, you know, you'd need to be able to distinguish between people. And that data set was interesting, but it was really big, and even as big as it was somewhat incomplete. You know, it was only a partial for the US, so if we wanted to actually just get some big high-level statistics, you know, that would not have worked. But the Atlantic has a couple data sets. The CDC has several data sets. There's I think it's like Our World in Data, a European group, has some worldwide data. That's pretty interesting. And it's all, you know, downloadable as CSV files, which can be imported into Postgres with a little bit of difficulty. Okay, so to learn a little bit more SQL here, let's see about answering this question. Does the number of cases overall in a state ever go down? Now, intuitively, we would say that's impossible. But the real world and the world of data, you know, sometimes disagree. But to answer this question, this is the key thing. We can include the same table multiple times. So if you look at this query here, I'm saying from all states history, and then I'm adding another name after it. This is aliasing or renaming the table, or just, you know, giving it a different name so we can refer to it twice. So the twice that matters is I want to say one time I'm looking at the table as the current day. Another time I'm looking at the table as the previous day. And just like we were able to join two entirely different tables, we can join the same table to itself. So here's the join condition we're doing. We are saying when the states are the same. But when the date is equal to current date minus 1 equals previous day date. And then we're going to say when the current day positive is less than the previous day positive. So let's run this whole thing, and then I'm sure that that's kind of confusing. So we'll try and explain that again. And here's what we end up with. Sure enough, we have one state somehow got rid of 7,700 cases. Another state got rid of 400 cases. And we've got a bunch of presumably just minor corrections that occurred. And, you know, this would be the type place if we were trying to make policy, or we were, you know, a news organization that was actually trying to, you know, find what's really happening. This would be the type thing. It'd be really interesting to look at this and see, how did the number go down by 7,000 here? That's a big enough dip. I'm guessing if we go to that 50 pages of this data is like this from this state and it's like this from the other, that there probably was some change in how they calculated it. Maybe they went to the antibody tests instead of the viral tests or some such thing like that. But this presents a pretty interesting anomaly here. But to get back to the SQL, this would probably be helped to visualize this a little bit. So let's do this join. Let's start with if we just did a cross join. So we have no conditions at all. So obviously this is totally wrong, but this is gonna get us a starting point. And it's also gonna break my computer because every combination of every row with every combination of every other row, well, there's thousands of rows times thousands of rows. So this will actually return some millions of rows, which I'm gonna Control-C to break out of this before my computer totally croaks. Okay, so total cross-join isn't gonna work. We're gonna need to constrain this a little bit anyway. So how about we say at least match the states together. So we're gonna remove this. We're gonna say that on, this is gonna be every combination of every state. And this is actually still gonna be fairly big. This is actually, I guess, another example of where it will be valuable to be able to get an intuitive grasp of how the joins work. Because the previous one, to start with the naive one and then filter it, was just too big. It would have taken an enormous amount of time. So what do we have here? We have the current day, state, date, positive, then the previous day, positive. Well, we can see, so these are definitely all for the same states because we have this constraint here of current day state equals previous day state. And so that part is right. But we have this idea of current day and previous day. Well, these definitely aren't right. We have the 26th of October as the current date and the previous date as the 6th of March. I mean, obviously that's totally bogus. So let's add in this additional join constraint. And just like we can use and or in a where clause, we can use it here. Anything that's a Boolean expression, well, we can combine Boolean expressions with and or. All right, here we go. So now this is starting to get interesting. We have the date, March 7th, preceded by March 6th, March 8th, preceded by March 7th, and so on and so on. And we can actually see what is the difference in the positive every day. And that's where we add, okay, now that we have that table that is basically the data we want, now we can filter it. And we will say where the current day's positive is less than the previous day's positive. Okay. And finally, to give some order to this, we will just add that order by diff. That's one other thing. You can refer to a named select column in the order. So rather than actually say order by current day positive minus previous day positive, we could do this and it'll work. But again, since I prefer not to type any more than necessary, and it's a good idea not to duplicate logic, I'll just refer to it as diff. I guess it's actually ascending.
I have a quick question. I'm not sure where I missed this, but where do we get cur underscore day from?
So that would be right here in line 8.
Okay.
So it is the all states history table. It's just we're going to name it something else. We're going to refer to it by a different name. Now, 99% of the time, you're going to do this because typing out all state history is kind of annoying. So you might just say, oh, I'm just going to call it H. And then everywhere else, I'm just going to say, H.state, H.this, H.that. But in this case, we actually want to look at this table twice. We want to look at it from the perspective of today, and we want to look at it from the perspective of yesterday. Or rather, when I say today and yesterday, we want to look at all dates and then look at all previous dates relative to them. So to reference this table twice, to tell them apart, we have to give them a different name.
Okay, I see. Thank you.
Okay, well, we're pretty much out of time on this lesson. There's a few kind of interesting things. Garbage in, garbage out is a classic computer term that goes back many decades, and it definitely applies with SQL. We can only give as good an answer as we have the data to draw on. In the real world, data tends to be really, really messy. And oftentimes the majority of time you spend getting an answer for a query is really just spent cleaning the data, understanding the data. Window functions and lateral joins, we didn't talk about those at all. Those are both actually really advanced features, but they could be really useful in this type stuff for, they're used to like compare one row with the previous row. Like we did this with a join, but what if we wanted to compare, like a running total or something like that? We could probably do it with a self join, but a window function would be a little bit easier once we understand how to do window functions. And then this is something that'll bear upon what Jake is going to lead us through next hour of when we're data modeling and we're trying to decide what sort of data are we going to track and how we're going to represent it. It's useful to look ahead and say, what sort of questions am I going to ask of this data? In this case, there's really important questions that have real world, life and death consequences. How infectious is this thing? How many people get sick and recover? Where are the hot spots? This is probably more important stuff than most of us will end up doing in our day-to-day jobs. Our questions will usually be more like, which product is selling fastest and makes the most profit or things like that. But regardless of what type of questions are being asked, we can only answer them if we have the proper data model and the clean data. Do we have any questions before we take our next break? All right, well, let's come back at 10 after 3, and then Jake is going to lead us through a data modeling exercise.
Jack, I think you're muted.
Hmm.
Were you saying something? Okay. All right, well, about time to get started again, looks like. Okay, so we've done like a pretty whirlwind tour of SQL. There's so much more to it, obviously. We're really just getting started. And there's a lot more just even in this project that that Jack.
We
Jake,
lost your mic there for a second.
How about now?
Good.
Okay, hardware. So yeah, definitely I suggest going back and looking at those exercises. There's a lot going on there, a lot to learn. For the last hour that we're together, so we're going to do something quite different for this hour, and then we're going to have 30 minutes of closing out the day questions and answer time. So what we're going to do for this hour is we're going to talk about data modeling. And this will be really practical for you all soon in your individual and team projects. Right, so there's a theoretical side of SQL, the practical side of typing into the REPL and getting the data you want out of there. And then I think there's also this whole other side of databases, which is how do you actually use it practically? And that's what I want to focus on for the next hour. So let's see, I'm going to start with the repository. So the data modeling exercise is kind of laid out here. Inside this directory, you're going to find a bunch of files that end in this mysterious extension called slurper, which we will be looking at shortly. Each one of these represents a domain, like an actual web application that my company built at some point in the past. So what we're going to do is we're going to take these files and we're going to reverse engineer that web application using the stories that or some of the stories we originally used to build those applications. And that's what each of these files are. Hashboard, HashRocket Bookstore, Oso Ani, and PGCast are all things that my company built in the past. And we'll be approaching one of these domains using something called the entity relationship model. The way the entity relationship model works is that you first figure out what are the entities. These are what are the things that we can represent. And for each entity, you then figure out what their properties are. And finally, you try to figure out the relationship between each entity. And we'll have some questions that kind of drive that. The domain we're going to be looking at is a web application called PGCast that we built probably about 5 years ago to host a series of screencasts my company made about Postgres. So very pertinent. The cool thing about SQL is all these lessons are pretty much still correct and accurate. So you can go back and like watch all of them and they still work on whatever version of Postgres you're on today. So when you're actually building your applications for your individual and final projects, how are you going to like start building them? There's so many different ways to answer that, and the technique of actually building can be so different for each individual. But I would kind of say there's at least 2 forks of ways you could go, and I'll talk about those for a second. The way that we typically work at HashRocket, where I work today, and where Jack and I work together for a long time, we use something sort of loosely described as agile. Agile is very true to that Sandy Metz quote I started the day off with. We'll never know as little as we know right now, so we should delay making decisions. So agile is all about doing a little bit of something and delivering it and doing that over and over again. So in Agile, or the way that we define Agile, you wouldn't really be doing a data modeling exercise at all. You could, but really what you'd be doing is you'd be saying like, how can I deliver a little piece of this, and what sort of data, what sort of data do I need to do that? And then you continue moving through the application. And the other is to sort of try to look at the whole application from a higher level and describe it before you get started. That's sometimes called pejoratively waterfall, or it's considered to be waterfall, where you're trying to deliver everything in the end. But I think what the happy medium there is this data modeling concept, where you sit down and you think about what the data model should be before you get going. And if you're good at it, you can save yourself a lot of pain building the application, because you've thought through a lot of the hard data stuff ahead of time. Some of my best applications I've ever built were built this way. Actually, a few of them with Jack, where we sat down and we really thought through the data model first. And so that's what we're going to do today. Any questions so far? Okay. So how would we do this data modeling exercise? Well, to start off, you have to do something called story carding. We don't have to, but it helps a lot. And that is what this file pgcast.slurper was. We used this file structure called slurper, which is basically just a tool for taking what you've written in the end and uploading it to a project management website. So it's just a file where people wrote these stories out, and then later they uploaded them to this project management tool all at once, rather than having to manually go in and enter each of these files. So what we'll start off by doing here is we'll read through a story, and then we'll model it out. Okay, so here's our first story. It kind of goes from these two little markers here, and we called it a feature. And then we gave the story a name. So we tend to write code in a behavioral driven tradition, which means the story should describe what a user would be doing on the application. So if you can't come up with a sentence like this, then you're not writing a story, you're doing something else. Visitor views the most recent cast. So just to make, this is always a little confusing, we called our screencasts, that's these videos, we called them casts when we were doing this modeling, where we were showing these videos about SQL. So that was the terminology we were using, was cast. It's kind of a weird word, but that's what we chose. So it has to be user focused. Visitor views the most recent cast. And then in the description portion, we write out what the feature is in this syntax that is sometimes called behavior-driven development. Rubyists will sometimes call it gherkin, but it basically uses these keywords: given, when, then, and. Those are the 4 keywords. So given sets everything up, when is actions that are taken, and then is like what the result is, and is just thrown around anywhere you want to add more detail. So this is how we write stories. And in our story carding session, we'd actually sit and write like 50 of these in a 3-day period. So given I'm a visitor, when I land on the PGCast site, then I am presented with the most recent cast, that's the most recent video. And for that screencast, I see an image, a title, an author, and a description. So how do you turn this into a database? Well, the way I would do it is on a whiteboard. So we're going to do that on a digital whiteboard here on this tool called Whimsical. So I took those stories and I threw them in this big rectangle over here on the right. And so here's that story again. Given I'm a visitor, when I land on the PGCast site, then I see the most recent cast, and for that cast, I see all these things. So basically, we'll walk through each sentence and try to determine when we need stuff out of a database. Given I'm a visitor. Okay, we're one sentence in. Does anyone feel like we need a database yet, given I'm a visitor? We have a web application. Let's just say it's like a blank page. Does it need a database so far?
No.
I think I heard an answer there.
No.
Yeah. Why do you say no?
Because you can have like a static website that just, I mean, the easiest way I can explain it is like you have a Linux box as your web server, and all it has on there is just like one line of text, "Hello world." No database needed for that.
Yeah, I agree. It's always debatable. That's why this is an exercise, because you can definitely, you know, Jack might bring something to the table of this conversation that I don't know, but about the domain that we might want to think about. But I would agree, based off just this sentence, I don't think we have a database. You can be, I mean, I'm technically doing that right now, right? I'm just visiting the site. I'm not logged in anywhere. As far as I know, the application doesn't really know anything about me. So, and you always kind of want to defer to not adding a table, I think, until you really need one, following that Sandy Metz kind of school of thought, you know, delay making decisions.
I have a quick
When
question on that, Jay.
Yeah.
So just the visitor concept, like from an analytics perspective, you know, if you just want to track hits to your page, would you offload that to like just Google Analytics then or something, or would you create a visitors, you know, table in your own database?
That's a neat question. For one of my projects that I've worked on, TIL, we have Google Analytics on here, but the problem with that is that developers are the main people who are reading our application, and developers love ad blockers. So many developers block Google Analytics. We thought that was a theory we had. So knowing our customer, we said Google Analytics is going to give us some information, but it's going to probably hide a lot of the people who are visiting the site. So what we actually ended up doing, and this is all open source, you can check it out, is we also built a different table that just counts every time the server satisfies a web request for a page. So in the case of our application, we know, hey, these particular customers of ours are very, very heavy on the blocking Google Analytics. So we're probably missing like a third or half of our traffic. But you can't block your browser requesting a web page. If you visit the web page, you have done that at least once. So it depends a lot on the customers. I mean, Google Analytics is like a you know, best in class tool, I guess, but like it might not work for your particular application. Does that make sense?
Yeah, thank you.
Yeah. So you definitely, on any kind of application like this, you want something like that going, so you know how many people are visiting. Very important basic piece of information. I'm sure there's Google Analytics on here. I tend to get really sidetracked, but yeah, if we look in the head somewhere in here, there's probably some GA going on. Probably blew over it. Google Analytics. Yeah, it's right there. So we are being tracked. Okay, so yes, we say, hey, we don't need to have a table yet. Then when I land on the PGCast site, doesn't sound like data yet. We still could be satisfying that with just the application. Then I am presented with the most recent cast. Okay, assuming we want to have a database at all, I think this is probably a call for something in the database, right? This is showing some piece of data, which is a screencast. So what we do here is we'd make a new table. I'm keeping this one over here as like a placeholder. So now we have to give this table a name. What should that name be? Well, we're using Postgres here, so we want to have a plural name, and we're going to do it downcase because, as Jack described earlier, Postgres folds everything downcase anyway, so it's just smart to have it be downcase. What would the name of this table be? I'll throw out some suggestions. I think it could be screencasts. I think it could be casts, although I hate that term the longer I do this exercise. Videos. Anything else? Any other ideas?
Lessons.
Lessons. Okay. Yeah, let's go with lessons. We've never done that before. We definitely, this is a huge part of data modeling, is that you really kind of wrestle with these questions and try to figure them out, because the name matters a lot. Jack alluded to this earlier. The name is one of the hardest things in programming, is coming up with a name, because once you have this name, you and every other programmer who ever work on this app are going to start to think of these things that way. And so if it's close to a lesson, which I think it is, it's a lesson about SQL, then that's a pretty good name. Whereas a name like casts, I would say, is kind of dated in 2020. We thought that was like a name, a popular name for screencast, but I don't really hear anyone using that term so much anymore. So the name matters, and it's not trivial sometimes to change the name. Okay, so we have our lessons table, and the next thing we need to do in our entity relational workflow, we've come up with the entity. Now we need to come up with the attributes. So what attributes do we need to go along with our lesson? I'll give a hint on this first one. Oh, yes.
Title.
Yeah, title. They're all spelled out here, and this is coming from like a stakeholder who was, a client or something, and they said, this is what I want. So title. What kind of type could our title be?
Various characters.
Yeah, I think so. I can't type. I see a comment coming in on chat. Make sure I'm. At my last company, the names of the tables were ridiculous codes in shorthand that had lost all meaning, and you just had to memorize which one you needed. Worthwhile to name them well in the beginning. Yeah, Augie, incredibly accurate. That's like when you get into a legacy code base, sometimes you just see the most ridiculous stuff. Like you'll see a table that's named like 0 lessons or something, because somebody wanted it to be able to find it alphabetically before some other table that started with L. Those type of little shortcuts are just, they're like the death of a project eventually. So we have to really be kind of a nerd about the names and like really try to get them right. Since we're doing since we're like breaking this table down really well, is this nullable, do you think? Is the title something that can be missing?
No, should be not null.
Why is that?
Because nobody could look for it if it didn't have a title.
Yeah. As Jack was saying earlier, like, or I think both of our general opinion is like most things should be not null. You should have to make a strong case for something to be nullable, because null has so many problems that make it so hard to work with. And what is the point of a lesson that doesn't have a title? I can't think of a good use case for that. So we're just not going to allow it. Okay. Then we have our title. I see a title over here. So we need that too. Oh, sorry. That's what we just did. We need our cast image. So how should we represent that on this table? There's some. Yeah, say again.
Thumbnail? I'm sorry. I keep speaking as soon as you do.
No, I want a participation. That's just, I know everyone's muted, so I don't mean to step on your mic there. Okay. Sorry, what was your suggestion?
Thumbnail?
Thumbnail. Yeah, okay. Sure. Yeah, that's a definite name for it we could use. Thumbnail. What kind of type should it be?
Varchar.
Yeah, sure. People have a tendency when they're getting into web dev, I think, to assume that like if you have an image, it's like an actual file of an image. But most of the time, that's not the case. Most of the time, it's pointing to a URL.
Could it be like an MD5 hash?
Yeah, talk more about that. Like the actual value is a hash of
The actual
that
value
like
is a hash to the location of the image itself.
Interesting. Yeah, well, I guess you could.
I don't know.
If
I've never built anything with MD5 hashes, but I think that's how it works.
Yeah. So what a hash does is it takes a value like a URL or a directory location, and then it basically like encrypts it in a long string that is it like points to something, but you have to have access to the original algorithm that created it in order to decode it. Does that connect link with up anything you've done in your work, Jack?
Yeah, so for the hash to be useful in this spot, you would have to be using like content addressable data, which would mean essentially the hash would be the URL, or it would be something you could construct the URL from. I've actually done this. In fact, one of my current projects does something like this, where uploaded files are hashed, and then the file name that they are actually stored with is the hash. And then if multiple copies of the same file are uploaded, they're deduplicated because they both point to the same one. There's no need to store multiple copies of it. But that's probably overkill in this case, would be my guess. But
Sure. Okay. That's great. So there's definitely like a lot of choices here. The simplest thing to do, I think, would be, or a solution would be to just have this be a URL. And so you might want to do something like thumbnail URL here, just to help the other developers to understand that this is not the actual thumbnail. It's like a URL that points to the thumbnail. And then you could have those images on a something called a CDN, a content distribution network, where there's servers all around the world that have that image. And so wherever you are asking for the image, there's a copy of it really close to you. And it's way faster than the web app. And that's just one way you could handle that. And lots of web apps will do that because images can be slow to load. So I'd say, since we're just going with things not being null, we're just going to leave that off. Everything is going to be not null until we say otherwise. But so this should be not null, I would say. You can write your code to be able to handle if it's not there somehow, but let's require this too. Okay, so now we need a description. Anyone have a type suggestion? We could do a string. And then lastly, we have our author. So in the world of this application, an author is a person who actually works at our company. So Mary did all of these, Mary Lee. But then if you start to get down a ways, you have Josh and Jake and Jack. And these are basically just they link to like our profile on the HashRocket website. So there's not a whole lot of information we know about them. But how could we, knowing what we know so far, how might we represent the author on this table?
An integer ID from another table of authors.
Yeah. Jared's suggestion is like one of the two roads you can take right here, I think. Or there's lots of roads you can take, but there's two that just jump out to me. I think when you're dealing with an object-oriented world that we're in, like we have an object called a lesson. Now we suddenly have a new object or something object-like, which is an author. And so you kind of have two ways you can go here. The first would be to make a table called authors. And then I need to reverse the arrow here because I want to say that this connects with this. Or I swapped those arrows around, and I would say the author has many lessons, and the lesson belongs to an author. Then that would be us drawing our first arrow of association between these two things. I don't know this. I don't know my tool as well as I wish right now. Apologies. Like that. The author has many lessons. The lesson belongs to an author. What are the, and then this would be gone. So when you're doing these association like this, you don't need to say author ID here, an ID. That's what the arrow is trying to tell you. So the arrow is trying to tell you that there's a, when you see this arrow, it's saying to us, there's a column on this table called author ID that matches up with a column on this table called ID. Also note, we didn't include an ID on this table, but of course we would. That was like the fifth or sixth thing we did with Jack this morning was add an ID. You'd want to have some kind of way that each record is unique, and ID is like the default way of doing that. So what is the, should we do this? That's my question to you. Is this a good idea to add this table?
I would say so.
Okay. What are the pros and cons of adding it?
Pros would be easily group like your lessons by author.
Yeah, you get all the benefits of a relational database, right? This author is like ready to go, and we assume that an author is going to need to have a lot of information stored on it, and we assume at some point in the future we're going to be saying, hey, who are all the authors? And we also might want to say, what are all the screencasts that go with all the authors, or something like that. And if you have done this from the get-go, you are really happy then because you already did all that. So that's definitely the pro of it. What would anyone like to help me think through like what a con of adding this table might be?
So if we were just going from just this one story, we don't really need it yet. We could just say author name and be done.
Right. That's what I was kind of trying to go for, and there's not a right answer. That's why this is hard, and that's why it's a fun exercise to go through even after you've done it a lot of times, because there isn't a right answer. But it depends on the priorities of your team. And on this team, maybe we're trying to move fast and we're trying to do things really simple. And we know that it's not going to be a big, complicated web app. It's going to be a simple web app that, isn't going to probably grow or change a whole lot once we build it. So we might just take the easier route and just say author name Barkar. We know we need the name just based off our designer gave us this design, and the only thing that it says is the name. So that's the thing we need to show. And if you do it that way, then you have kept your work completely. If all you ever got was this story, then I think this is the right thing to do. If you can tip your hand and see that you're going to need to do more, then yes, add the other table. But that's kind of why it's cool to do data modeling first, because by the end of this little exercise, you'll have answered that question and you'll know. And then when you start writing the application, you won't have to guess anymore. You'll have thought it all through. When the way we work at HashRocket is more like we actually do this whole thing and deliver it, and then we go into this one and do this whole thing. So if we were doing that and we hadn't done data modeling, we would have shipped it like this, and then later on we would have been like, man, we should have made that. It would have been cool to make that into another table, and then you do that. It's not like it's impossible or super hard to do, but it costs something. Okay, so we've done one story. We have data modeled one story. The next story says, visitor views a list of recent casts. Given I'm a visitor viewing the homepage for PG casts. Oh, sorry. We left something off. Then I am presented with the most recent cast. What makes the lesson that we're seeing here the most recent one?
Upload time.
Oh, nice. Upload time. Right, sure. Let me write that out. Let's see how it feels. Yeah. And what type of data type should we use there? Be a timestamp.
Timestamp, that one, yeah.
With that TZ on there.
Right.
And we'll say that's not null too. All of these records, if we're using Postgres, well, I'm not sure if it's a Postgres convention or an ORM convention to have created at and updated at. But
yeah, that's an ORM. That's a Rails and Django thing.
Rails and Django and most ORMs are going to give you 2 more columns. Well, Rails will give you created at. I don't know what it's called in Django. And it will give you updated at. In Phoenix, this would be called inserted at. But you always, using an ORM, you always get these 2 columns too. I mean, they're just part of what you receive when you make a table. So could we use either of these in place of upload time, or is upload time something that should be standing on its own? It's a little bit of a trick question, I think.
Or is there
we
another
didn't-
type of time we should have as well?
When it's created, isn't that when it's uploaded?
This is I'm really glad we got into this, because we usually cover this by this point in the day, but timestamps they carry some interesting meaning to them. In your object relational mapping, your created at timestamp is managed by the ORM. And it is actually the time the record was created. So if you're sitting around, let's say you're building this web app today, and you're like, okay, I'm putting in my first lesson. I'm going to put it into my database. Here I go. You save that record. The timestamp is now. And also updated as now too. Now, like literally meaning 1644 Eastern time, October 27. And we aren't meant to actually touch these ourselves. The ORM does the work of managing these. So every time you touch this record, Django ORM is going to say updated at it's now, and it's going to keep changing. It's going to be whatever moment you update it. And created at is meant to really never change. Once it's been inserted into the database, that's a permanent timestamp. So a best practice is to never mess with these. Now that we know that, are these still, do we still think these are good timestamps to use for determining the latest screencast? My argument here is no, because like if you follow that example, you're setting up this web app before demo day and you put like 15 records in all at once. They don't have any kind of meaningful order. They were all created within like milliseconds of each other, and I want to be able to actually say what is the most recent one by maybe doing
Couldn't you
something
go off the
like
primary key?
the primary key is interesting because it's the same situation, right? Like if I'm sitting there, this is the night before demo day and we're like creating our database and I put in 15 records, they're going to get IDs 1 through 15 in a deterministic, but not, I guess actually the way you insert them will determine the ID, but they'll get ID 1, 2, 3, 4, all the way up to 15. That ID is like not really, it happens to map with the order that they were put into the database, but that's kind of almost a coincidence, I think. Like if you had inserted them in a different order, then they would be in a different order. You don't really have a whole lot of control over which one is the latest one. You have to perfectly put them in the database in the right order. Does that make sense? So like, let's say let's say I have a video from a month ago and I want that to be the latest video. In that type of situation, I'm kind of out of luck because I'd have to give it a newer ID and I'd have to like change its ID. And that has a lot of bad side effects and is just kind of a problem. In a relational world, there might be other tables that expect that ID to be a certain thing, and then I've changed it, and so I could have a author that says one of my lessons is lesson number 1, and then I change the ID of lesson number 1 to be 80 or something. The database doesn't know what to do with that. So a common way, or a way you could handle this is you could say publish that. That's a timestamp too. We'll take these off because they're just always assumed to be there. I think upload time maybe was kind of going for the same kind of idea. These are equivalent in my mind, but then I can say when I upload the record, this is published at, I could say it's tomorrow. I could say it's published at 10 a.m. tomorrow, and then maybe I filter on the web app by publish that. So if you look at it at 9 o'clock tomorrow, it's not there. But if you reload the page at 10 o'clock, it is there. That's kind of an awesome benefit of doing it this way. So yeah, we'll stick with upload time. But
this process here, an advantage we get from it is it gives us new questions to ask. So lots of things like we're going back and forth with, as the developer, we're not necessarily the one who's supposed to make that decision. But we start going through this story and we see, oh, well, what exactly do they mean by most recent? And then it's like, oh, well, published maybe. Okay, does that mean you can have articles that aren't published? And you end up, it gives you a lot of questions to ask the stakeholder, is generally what we refer to the person who's making the decisions.
Yep. Right. It's kind of cool when you get good at this stuff. Then you're like, people feel like, you ask really good questions, but the process of doing this makes those questions kind of deadly obvious, because we have to actually answer right now. We have to say like, what is this? How are we going to do this? And there isn't an obvious answer. So it's a great point that you can take that back to the client. Okay. So let's go through the next story quickly. I don't think it actually calls for more records, but we'll see. Given I'm a visitor viewing the home page When there are recent casts, then I see a number up to n of recent videos. And those videos are sorted in descending order by date. And for each video, I see the thumbnail image, the title, and the author. Okay, so we're good. This whole story doesn't require any more data modeling. It's going to take more coding to make all this work, but we have all the data. Okay, next story. Visitor views the show page for a cast. So that is when you're viewing an individual item, we call that show page. And I want to point out something kind of cool or interesting. This URL, it doesn't have a number in it. You might be used to, when you're building like new web apps, you're sort of figuring out to see something like this, right? Episode 22. But this doesn't have that. Let's just assume that was in the design. And when we started building this, we noticed that, like, the designer said, I want this to be at this URL. How might we accomplish this, or why might we even want to do it in the first place? That was two hard questions stacked on top of each other. Let me ask the more important one. Why might you want to do this? Why might you want to do it this way?
So it's easier to navigate to the lesson that you want.
Okay. How so?
And instead of memorizing which exact episode it is, okay, I'm looking at the geolocations using PostGIS.
Sure. Yeah, exactly. That's not the most easy to remember name, but how about like Nullif or less, right? Like I can remember this URL just looking at it as long as I've looked at it now. I could type it in from memory. So that's kind of cool. It also helps with SEO, or it's thought to help with SEO if the URL is, I don't know how much truth there is to that, but I don't think it can hurt if the URL actually is like human readable words instead of numbers. There's another really cool reason to do it this way too. When I show a URL to the user like this, what do they know? What do they know about my database? Okay, what can they figure out?
They're on episode 22.
That's true. Keep going. What else can you figure out?
That'll probably be like the primary key for that video in the database.
That's most likely correct. Yeah, absolutely. So I'm telling them something about how my data is organized. They'll probably assume that, but I'm showing them, hey, this is how I organize my episodes. It's by an ID that's a number. Anything else?
They probably know there's 21 more before that in that database.
Yeah. Yes, exactly. So it's not a big deal on PGCast because you could just go to this main page and count them. But what if this was like users and I'm a business with competitors? I don't want my competition to be able to come in here and see that Jake has like a website with 2,330 users, because then they can figure out how good my business is and how much of a threat I might be. And then these numbers aren't always going to be sequential. Even though you might have made 233 records, you might have deleted a bunch of them. So, it's a little nicer to have like a string here instead of like somebody comes here and they say, oh, 22, I wonder if there's a 23. And then they get like a 404 page. So that's a reason you might do that. So if we were to model this, how do you think this is done? This episode's called Coalesce, and there's the word coalesce in the URL. How might we represent that on this table?
By making the title the primary.
Interesting. Yeah, well, you could definitely make. I hadn't thought of that. The trick with the title is that the title is actually, in this case, that would work okay because it's just one word. But in the case of something like this, the title is actually going to be this string here. So it doesn't quite turn into something like this. It doesn't quite turn into a downcase string with dashes between the spaces, but you could have the title be a primary key, and then I guess you'd have to like transform this in your routing layer into something like this. One way that people might approach this is they might just make a new column on the table that's like the URL hash or something. I don't even know what term I would want to use. URL slug. Slug is a term you see a lot of times for it. And you could have this be when you create the record in your Django code, you could have this read the title and transform it into a slug like that. So if the title is, SQL is great, then you could write a Python function that turns that into SQL is great. And then, yeah, you could have that be your primary key. I don't see why not. And you might want to make it so that it never changes. Like you might want to say, I can iterate on the title as much as I want, but that string will stay the same. And a reason to do that is if like I've shared this link with you 4 years ago, and I keep making the title more of a clickbait title, this URL will always continue to work. Okay. Okay, so that is maybe a way that we've started to represent this this story here of the show page. And I would say when you're working with a client, this is a great opportunity to have a conversation. Like, this is something I saw in the design. I think it's a good idea for the following reasons. Do you want us to do it? Like you kind of, a client or the person you work for, you kind of make the argument based off the stuff we just talked about. Okay, so we probably can finish this story. Given I'm a visitor viewing the landing page for a cast, when I click a cast, then I am taken to the show page. And for that cast, I see a video player, title, author, description, and tag list. So there's 2 new things here that we didn't have before. One is a video player and one is a tag list. And that's there's only one tag I think that we ever even made, but here it is, Postgres version 11. Okay, so let's try to hammer these 2 out and then we'll wrap up. Video player. How do we put a video player onto this? I'll give you a hint. This video has been provided by a popular video service you may have heard of.
With the embedded link.
Yeah, that's how we chose to do it because it's really easy, and we thought it would be cool to put it on YouTube. So we did like YouTube embed URL, something like that. That's a character array again. Man, we're getting a lot of use out of that type in this table. Okay, so now we have the video. You just have to do the work of uploading the video to YouTube now. That's like separate from your web app. I think depending on a service like YouTube is not a bad bet to make. Okay, the last thing that I have is the tag list. So we want to have tags. On this, I don't even know what kind of tags we ever made. Here's one, Postgres version 11. Here's one, Postgres version 11. See if I can go 3 for 3. Postgres version 11. Okay, so how could we represent this in the database? We need something that has a concept of a name attached to it. I think we might be getting into a realm of another table here. So the very the very naive thing to do here would be something like this. You know, tags. Postgres has an array type, right, Jack? I think.
Yeah, you could do an array of varchar.
Right. I'm just gonna write it that way. This would be like the most naive possible thing you could do, is just say, hey, there's an array on each of these and it has tags in it. That might be good enough. You know, it's probably not, but it really depends on what you're going to use these tags for. In the case of this app, we never actually really did anything with them. It's just some text here. I think we had a big vision that we were going to make this like, you click on the tag and you see all the stuff for the tag, but you know, we never did that. So that might actually be, I probably would never suggest that on a production app, but for like a hobby app, like that could be good enough.
Yeah, this is actually a really good point, what he said of, we were thinking we were going to do this stuff and then we never did. This is the opposite side of plan ahead and like build the tables for everything. Well, in this case, to do it right, quote unquote, you know, we do a different table. It'd actually be a couple tables. We'd have a couple for tags, or a table for tags. We'd have a join table that joins posts or lessons, we called it, and tags. That would be the right way to do it. But since we never actually built all that stuff, we would have done a lot of work that we never got any value out of. If all we're going to do is just show a little text at the bottom, all that extra tables was wasted time.
Yeah. If I could impart one idea today that colors this part of the exercise, it's like there's a concept called YAGNI. Have you all heard that before? YAGNI. It stands for you aren't going to need it. You aren't going to need it. Even as a seasoned programmer, it's really beneficial to look at an exercise like this and be like, what do we actually need? Do we need another table called tags? I'd say right now, probably yes, but it's really on the bubble. So I would, if I was talking with another programmer about it, I would really kind of hash it out and kind of, I'd argue whatever side they weren't arguing just to like make an interesting conversation. In the end, we'd try to get it right. You aren't going to need it. A lot of times you don't need things. And another table equals another Python class. It equals more validations. It equals more, another thing up on the chart when a new developer comes in that they have to learn. There's always a cost to adding this stuff, and it compounds over time. So you really want to fight against adding stuff if you don't have to. And finding the balance between that instinct and like, you know, the best practices you know of is like part of what makes data modeling an interesting exercise. Okay, let's take a quick break because it's been about an hour since we've done that. Can we meet up at 10 after and we'll do our Q&A? Okay, time at the end of the day, till say about 1/2 to just, or longer if needed, to answer questions you have. So you know a little bit about our backstory and where we're coming from. We both have been Chicago based for a while, so there's that. And then we have both taken very different paths getting to where we are as software developers. So I'd be happy to answer any questions you might have.
Did you start with a job that was similar to this, or like how did you go from finding like this is what you wanted to do for a job?
Yeah, so my short version of my background is I was in the Army from 2005 to 2010. I was an armor officer, and when I got out, I didn't really know what I wanted to do, so I took a couple of different jobs to just explore. and one of them was a office manager at an IT company. So I saw technical people. I had no programming background at all. I saw technical people and I saw what they were doing, and I got really interested in it. And so I decided to try to teach myself to program. This was 2012, the same year that Dev Boot Camp was founded. So there weren't a lot of boot camps, especially in LA where I was. So I decided to try to teach myself, and that's what I did. And so once I started going down that path, I just didn't really look back. But it was a lot of chance that led me to that path in the first place, I think. Jack should answer that question first because his answer is better than mine.
So, boy, that is a good question, though. I guess as I was doing development, had to do some, you'd had to design a database along with the application. And just more and more, I felt that that was the important part of it. So I ended up focusing on it more and more. I also found it really valuable in the sense of just like career planning, that it's a skill that doesn't really go out of date. If you were an expert in SQL 20 years ago, 95% of what you knew is still perfectly valid today. Whereas a whole lot of the technologies like Node didn't exist 20 years ago. Python and Ruby did exist, but Rails and Django didn't. So you weren't likely to be using it for web development. If you were doing anything back then, you were maybe using Perl, something like that, or CGI bin scripts. SQL is a language that survives. Jake and I could just list for probably 10 minutes just different technologies that we've had to learn or we've chosen to learn and now are totally useless. And SQL is one of those that actually lasts a while. So, when you've spent a lot of weekends, a lot of nights, a lot of time, during work hours studying and learning something, and then to find that that's useless to you now, you try to avoid that in the future. And SQL is one of those things that it's lasted for 40-ish years, and it doesn't really show any signs of, being obsolete anytime soon. So it's been something really valuable to focus in. From the programming side, you've probably noticed it looks way different than anything else you've done. It's a fairly unusual language in that it is declarative. You don't actually say, go read this file, now advance 10 records, now go 6 bytes to the left, now do this. What you really are doing when you create a select statement is you're telling it the result you want, and it figures out how to do it. We referenced that briefly with talking about indexes, where depending on if there's an index or not, the work it actually does will be entirely different. So that type of programming model is also really useful. When you think about how would you do some of these things in Python, even just the stuff of, select all these values and average them together. Well, it's easier to write, select average such and such column from table than it is to say, loop over this or do a comprehension or whatever and, add all these things together and then divide. So for a lot of types of tasks, it's also the easiest way to do it.
Yeah, for me, I got into consulting around the time that I met Jack, and consulting is an interesting path for a programmer because you're, especially a general web dev consultancy like HashRocket, you kind of have to know it all, at least pretty well, and you sometimes just get thrown in the deep end on something. Sometimes someone comes in with a really hard SQL problem, and you're the person who's free to work on it. So the nature of HashRocket keeps me really constantly getting up to speed on the different parts. As soon as I've drifted away on Postgres or something, I'll get pulled right back into it, and then I'll do something really hard with Postgres for a couple months, and then I'll spend a whole year on a big React project. So you're kind of just, it's a little bit disorienting consulting. You're kind of just always like going somewhere else and doing something different, but that's kept my feet, you know, planted in SQL this whole time. I agree with Jack. It's like a timeless technology. So my personal interests are more like in JavaScript single page applications. Like that's what I've spent more of my time doing, and more of my expertise is in that. But this class and also my consulting work keeps me really grounded in SQL.
I had a question. So, Jack and Jake, Jack, you mentioned earlier the terminal emulator, I guess, if that's what you want to call it, that thing. You said you would share that plugin, and also that's the first question. Second one's related. What bench or dashboard or GUI do you use, you know, to visualize data outside of that tool, or do you just specifically stick in the terminal, you know?
So first I'll paste the name of that thing into the chat here. It's just called PSPG. And you can, if you're on a Mac and you have Homebrew installed, which you probably would, you can just brew install it. And then you set it, I'm sure it has instructions in the documentation, but you set it in your pschool.rc file. For visualizations, most, or even just a GUI tool in general, most of the time I just work in the terminal. Really would be nice to use a more graphical tool for like exploring data, and they do exist, but just for my personal workflow, I usually just stay in the terminal.
Yeah, we both came from, or we both were shaped by our time at HashRocket, and HashRocket has a very terminal focus. So everyone who works on our team typically uses Vim as a text editor, and we do most of our work at the terminal. There's a chapter of the book, The Pragmatic Programmer, that makes this argument like a lot better than I could, but there's definitely a benefit to being able to do it that way. Having great graphical user interfaces is good, and knowing how to use those is maybe helpful, but sometimes you don't have those. Sometimes you're SSH into a server and you have to go into pSQL. And when that, you know, when that disaster strikes, it's like really awesome to have that be your native way of doing it.
Right, and another thing, just as far as the terminal, like command line focused way of working, is it's scriptable. And that's like a big deal. Everything in pSchool you can script. You know, if you're using a GUI tool, it may or may not have, you know, some sort of scripting hooks, and they're probably, you know, different. Maybe, as Jake said, that tool isn't available. But like, we only scratch the surface of what pSchool has. I mean, you can write entire scripts in it with like if statements and, you know, all sorts of crazy stuff. And that's really useful when you need to have some complicated process that you need to reproduce to have it be scriptable.
Thank you for that. And I guess while you're here, related and unrelated, you said you both use Vim. I've started to use Vim, quite a learning curve. I started, 6 months ago. I'm just to the point where I'm comfortable, now. And I was wondering if you guys use the Vim plugin for VS Code, and if you have any like tips for that, because I found that kind of lacking in some cases, like with the search and replace. I run into errors and issues. Or do you use Vim as your overall code editor, or do you just use the plugin for like VS Code?
I'm still pure Vim. Like HashRocket, it's kind of the way most people work, and it's like the thing we all share is that we're all Vim users, or it's a thing we all share. I love that it's just kind of like this unchanging text editor. It's been around for 30 years, 25 years. it's like my rock, like that I have that, that's the one thing I can count on, is that I know how Vim works and I'll always use it. I've tried to use VS Code a little bit and I always kind of fall back to Vim. So I'm just a Vim user till I die. How about you, Jack?
So I guess I'm the heretic here. I use VS Code with the Vim plugin. Before that, I used Sublime with the Vim plugin. VS Code is like both the best and worst text editor I have ever used. It's like the best in that it has all this stuff, and it's like the worst in that it constantly is like slow or crashing weird, or like you mentioned, the Vim plugin just like mysteriously does something crazy. But as far as it goes, the Vim mode is pretty good. But the way I use it is I use it for navigation and manipulation, but I don't use it like for searching. Like for search and replace, I'll just use the VS Code search and replace. And for file navigating between files, I use Command P or the sidebar. I don't try and use whatever stuff it has. And I think it even has like a primitive like extended mode. Like I don't even touch that in VS Code. To me, it's the intraline, inside the file, that navigation is where it's really cool. And there's a few plugins that are really cool. I can't remember what it's called, but there's one where you just hit S and then you can type 2 letters and it just jumps you to the next one of those 2 letters. It's like a better F key. So that's like my favorite plugin there. I know that exists in regular Vim as well, but I can't remember what it's called there.
Yeah, I would definitely say if you're interested in Vim or you're like trying Vim, like it's hard. It is definitely hard in the beginning. That steep learning curve you described is everyone goes through it. And I think it really is worth it to try to learn it. Like a lot of my programming heroes, like a lot of them are Vim users. A lot of people I look up to. It's not the only text editor out there, but it's a good one. It's a really good one. So I think it's worth sticking with it and trying to figure it out. You all probably know this, but Alpha Platoon of Code Platoon, they all had to use Vim. I don't know if you ever heard that. Their teacher made them use Vim. Josh Cheek. So that sounded really hard to me, to like be learning programming and be learning Vim at the same time. It's like, whoa.
I'm gonna ask my mentor about that. He was an alpha.
Yeah, I don't know if they all are still Vim users today, but that's a technique to do it. You throw right in the deep end. Other questions we can answer while we're here?
I have a question. Since we all have like like interviews soon as developers, what would be like common SQL questions about SQL or database? Is it something like general knowledge, or is it something like specific comments, or if we don't the answer, how would be the best response to that?
I need to think about that for a second. I did junior developer interviews a lot more recently than Jack, so my recollection of them was that they were really a mix. Interviewing is a pretty wide range of experiences. For some of them, they wanted me to do like algorithmic things, sort of like code katas. So you can practice those with like exorcism. That doesn't have anything to do with SQL, but sometimes people just want to see you write like a FizzBuzz or whatever. And then I had the closest I came to having questions really about the database, where I had a couple interviews where somebody wanted me to walk through like handling a web request. I feel like that's kind of a common interview question, is like, how would you deal with like what happens when I click a button on a website? What happens when I like tell a browser to load a website? And they kind of just want you to walk through it all, and the the things that you say will reveal how much you know about how the internet works. That's a pretty common. I've gotten that at multiple levels in my career. So I would, if you never thought like how does a website work, maybe take a second and think about it. So there's nothing about that that is specifically database related, but my knowledge of databases came in handy there because I just threw in some knowledge about what the database might look like to handle the made up requests we were talking about. I don't know, your mentors might have better answer to this than I do, because I don't feel like interviewers are going to be like asking real specific syntactical questions about Postgres. I'd be interested to just hear what a person thinks. Like, do you have a database that you prefer, and why do you prefer it? How would you change something in a database? How would you add a column to a table? And if the person said like, if the person was just a blank, then I would think they have never done it before. If they said write a migration, I might be like, oh, cool, you know a little bit about ORMs, and tell me what you think a migration would look like. And I don't know. Jack, do you have a better answer than that?
I don't know if I have a better answer. I have some thoughts on it. So to specifically answer that, like the type of question that, like I would be asking, if I was interviewing somebody, is like, what would you use a foreign key for? Just kind of, not like Jake said, not syntactic things, but just basic understanding of, what is a join? Why would you join things together? Just to get a sense of like, do you know much in the way of SQL at all? And I guess another thing is, as a very like junior or entry level thing, again, kind of sitting on the other side of the desk, I don't really expect a junior dev to, there's going to be a lot of holes in what a junior knows. It's just a matter of where the holes are. So I'm not necessarily looking at, oh, well, they have to have A, B, C, D, and E. There's a whole alphabet of things that you eventually need to know. Show me which parts of it you know. And if you know any of those parts very well, that's a very good sign. You can't, as in your first job, you're just not going to be able to check all the boxes. The closest you can get is basically, what you're going to be trying to do for your final project, as I understand it. Like back when I was at HashRocket, and Jake and I were actually involved with interviewing and hiring one of our then coworkers, actually wrote like 20,000 lines of JavaScript, like in a single file. It was horrible. I mean, it was messy. There were all sorts of things wrong with how it was architected and designed. But here's the thing. He went from nothing to he made a thing, and the thing worked. That is like the big thing that sets somebody apart from, that sets you apart from the pack. Can you do a thing? Can you start with nothing? And even if it's practically just a to-do list where I started with nothing and I can go to, this is now deployed and running on the internet. And I can do all the steps along the way. That is like shockingly rare, actually. So that's what I look for anyway.
Yeah, that's a great point. That's like one of my strongest recommendations for anyone who's like starting to learn to code is build up the muscle of finishing stuff. It's so easy when the difference between a person who's like dabbling in programming and a programmer, I think the big difference is like the programmer doesn't get to stop. You have to actually finish the project. And it's really easy when you're, as a hobbyist, it's really easy to say, oh, I don't know how to do this, so I'll try something else. But, our job is to finish things, and and if we can't figure it out, to figure it out. So if you start a little algorithmic idea, or you do a little exorcism, or you're building a web app on a weekend, like try to find a stopping point and get to it. And it's going to be hard. There's going to be multiple moments where you're going to be like, I just don't know how to get through this. The getting around that thing, that is the job of being a programmer. You're even as a more experienced person, you hit these walls where you just say like, I don't know how to do this. And you want to start building up the confidence now that like, I can figure this out. I can get around this. I can ask the right person, and I can figure it out. That's a strong thing that I think junior programmers should focus on. New programmers.
Thank you.
Can we answer any other questions? We have a little bit more time. Well, I guess that brings us to the end of the day.